Excellent.
Secrete.
How did biochemistry go?
Good. Awesome.
Awesome.
We had like 50 people in the beginning, so yeah.
When Dr. Miller used to teach biochemistry, they had like 15-point curves.
That's the opposite. Dr. Miller used to teach biology.
All right, we're going to start with nerve.
That would be bad, yeah.
And with nerve, we start with the central nervous system. We're going to look at a cross-section through the spinal cord. And if we take the spinal cord up so that we can see the structures, remember that you're going to distinguish between grey matter and white matter. Grey matter being the central portion that looks like a butterfly, the white matter being the part on the outside here. And the white matter contains mostly axons, right? Myelinated axons, very good. And then most of the cell bodies, the neuron cell bodies, are going to be sitting down here in your grey matter. And remember, we have anterior horns, the posterior horns, the lateral horns are these little ones, these sort of little bumps that we see on the side here. Posterior median sulcus, anterior median fissure, and then the central canal lined by the ependymal cells. And remember, these are little cuboidal cells that we see. Now, for looking at the motor neurons, we magnify up the grey matter, and we start looking for these very large cells. And remember, the cells are large enough that even in a single cross-section, you may actually see part of the cell body but not see any of its nucleus. So with many of these, we can see that these belong to large cells, but we don't see any nuclei associated with them. So we can back off a bit and then go and look for a nice example. And here we have an example of the neuron cell body. We have a nucleus, we have its nucleolus, we have these little blue granules sitting in the cytoplasm are the Nissl granules. And what are those Nissl granules? Mostly RER. And what would you expect to have with the RNA? RNA, okay. mRNA. The other thing that you can actually see on here, which is quite nice, is you can see the axon hillock. This is the sort of paler region in this particular one that you can see quite nicely. Any issues with the spinal cord? If not, we're going to go on and look at the peripheral nerve. We'll start off by doing the cross-section through the nerve. And here what you can see is we have a nerve, a very large nerve that has these little nerve bundles associated with it. And take it just down to very low magnification initially so that you can see that the tissue actually extends all the way around here. So we've got lots of loose connective tissue surrounding each of these little nerve bundles that we see. So this connective tissue here all represents the epineurium. In that case, when we start looking closer up and you start seeing this more dense connective tissue, what is this going to represent? It's perineurium. And then, ergo, if we go all the way up to very high magnification, now we've got this pale connective tissue in between these structures, and this is endoneurium. We have here nuclei. These nuclei are nuclei of what? They're Schwann cell nuclei, and there are also what other kinds of nuclei? These long, skinny ones. We're sitting in connective tissue. Fibroblasts, very good. Now, the blue donut that we see is, it's myelin, all right? So it's the Schwann cell itself making its myelinated sheath. And then the white space in the center is? It's an axon. Very good. So what we have here is we have cross sections through myelinated nerve fibers, and those nerve fibers are axons. And so we can see the axon, the myelin sheath, we can see the Schwann cell nuclei associated with that, and it's probably best if we're looking at Schwann cell nuclei to see the nucleus that's actually attached onto the myelin. And then in between here we have the endoneurium and resident fibroblasts sitting in the endoneurium. Are you all comfortable with that? Now if we go and look at this under a longitudinal section, when you have a longitudinal section, now we have all of the axons running transversely across the slide here. And now, when we look at this under slightly higher power, we have these white regions, and so these white regions represent the axons. Again, the little blue stripes are going to be the myelin, and in between those, the pale connective tissue is endoneurium again. And when we have long sections like this where we have the axon continuous, what you'll have is there are individual Schwann cells around an axon at any one region when it's myelinated. But one axon, as it travels down, will have multiple Schwann cells set one after the other down it. And in between those Schwann cells, we're going to have a structure, like this structure at the left of the arrow here. Okay, and these are the nodes of Ranvier. All right, so nodes of Ranvier.
So what is the node? Where's your arrow pointing?
So my arrow is pointing to the left. The little left arrow on this one. This is the node of Ranvier here.
Okay, the little purple.
Right. So it really, you can see this is one Schwann cell coming down this way. All right, this is one Schwann cell. Here is another Schwann cell coming up and around this way. All right, so that's two Schwann cells. In between the two Schwann cells is the node of Ranvier. Remember, even though it doesn't look like it here, this axon is obviously continuous through the node of Ranvier. Now, we said that what you should not do is you should not confuse those nodes of Ranvier with the clefts of Schmidt-Lantermann, which are the little V-shaped clefts that we tend to see in a lot of the places. So, of course, when we start looking for them, then we can't find them, and when you don't want them, they're all over the place. Again, here's another nice node of Ranvier. Here's a very nice node of Ranvier. Can you see those? Right, where there obviously are between two Schwann cells, between two myelin sheaths. The clefts of Schmidt-Lantermann tend to be these more V-shaped structures that you start seeing, and those are not nodes of Ranvier.
on the practical, Dr. Opperman, do you just ask for bolded terms